All right, guys, we're doing the Matrix 3 lesson. So we're mainly going to talk about determinants and inverses. So the determinant, in order to find it, is AD minus BC. So we just got to know what AD BC is. This is your A spot, this is your B spot, this is your C spot, and your D spot right here. One thing I forgot to point out is we're mainly going to be talking about 2x2 matrices. You can also find the determinant of a 3x3, but we're not going to be as worried about that. So anyways, it's AD minus BC, like I mentioned earlier. So this is 2 times 4 minus negative 1 times 1. It's going to end up being 8 plus 1, and that's going to leave us with 9. So the determinant of that first one is 9. The next one, we've got 4 times negative 3 minus negative 2 times 6. So this is going to give us negative 12 plus positive 12, which is 0. When the determinant is 0, that's going to come into play later. It's a special example, but we'll talk about that in a minute. 3x3s are a little bit more difficult. So what we're going to do is we're going to start with the top numbers, right? So we're going to focus on these ones. And we're going to start with the top left number. Okay, so we're going to start with this 2. One way to think about it is it blocks out the other numbers in its row and column. So we're going to ignore these ones right now, and we're just going to focus on the 4 that aren't crossed out. So basically, we are going to find the determinant of those 4, and that's going to be done the exact same way as we would any normal 2x2. The number in front, the first number we chose, is going to multiply the product and difference of the other numbers. So it's going to end up being 2 times A times D, so negative 1 times 4, minus B times C, which is going to be 0. We're going to come back to this later. I'm going to erase this stuff now. And again, we're going to focus on the top numbers. Now we're in the middle, right? So we're on this middle 2 right here. We're going to block out the other numbers on top and the ones in the same column. And so now this is going to subtract from that determinant. We're going to use that 2 again. We're going to find the determinant of the 0 on the left. This is my A now. This is my B. This is my C. And this is my D. Okay, so now it's minus 2. 0 times 4 is going to be 0. And 0 times 3 is going to be 0. The final one is going to be the 1 in the corner, right? This is where we're looking. We're going to cross out, same thing, we're going to cross out the same ones in the same row and the ones in the same column. That 1 we're going to add, and it's going to be, that's too big of a 1. Let me try again. There we go. So now we've got 0, negative 1, 3, 0. So it's going to end up being 1, 0 times 0 is 0, minus negative 1 times 3, which is negative 3, but we're subtracting, so it's going to become positive 3. So the answer here is going to end up being, we've got 8 minus 0 plus 3. Yeah, so it looks like the answer to this is 11. The determinant is 11. A lot more of a process there with a 3x3 than a 2x2. You always use the top numbers as scalar multipliers and the bottom numbers as different configurations of a 2x2 determinant. The one thing that's not, readily seen, I guess, is this is always going to be subtraction, and this one is always going to be addition. Okay, so between the first two matrices is going to be subtraction, or determinants, I guess I should say, and the second two determinants is addition. Alrighty, so let's take a look at what we got. So the inverse of a matrix, the product of these two matrices, if you have a matrix times its inverse, right? It's the identity matrix. So when you multiply these two together, we're mainly going to be talking about 2x2s. It should be 1, 0, 0, 1 when you're finished. Okay, so in order to find the inverse of a matrix, you need to find the determinant first. It's going to be 1 over the determinant. That becomes your scalar multiplier, and then you multiply it by every number inside of the matrix. So let's find the determinant first. The determinant of, I'm going to call this, just to make it easy, I'm going to call this matrix A. Okay, so finding the determinant of A, sometimes you'll see the notation as this. It looks like the absolute value of A, but this is also asking you for the determinant. All right, so both of these are used, and they're both asking for the same thing. So we want 2 times 0 minus 1 times 3. This is going to end up being, what do we got here? -3. Looks about right. So that means when we're finding our inverse, it's going to be 1 over -3. And then our original matrix, 2, 1, 3, 0. And then when I use my scalar multiplier, it ends up being -2/3, -1/3, -1, and 0. Here is the, formal equation, if you want to say that. Oh, I made a mistake. Yeah, let's go back and fix that. I forgot that you have to switch your values. So if you'll notice, it's always good when these happen, just a quick mistake, we're going to correct it. Point out the importance of this, right? So normally it's A, B, C, D, right? So if you'll take a look here, the D and the A switch spots, and then the B, C are now opposite signs. So if it was negative, it's positive now. If it was positive, it's negative now. So let me do this the right way. So that means the 2 will actually be a 0. The 0 will become 2. The 3 will be negative, and the 1 will be negative. So now here's the correct inverse. It is 0, 1/3, +1, -2/3. And there we go. Much better. All right, this is what I was talking about earlier, this section. The inverse exists if and only if the determinant does not equal 0. Okay, I mentioned back up here, right? Special case, when the determinant is 0, that means that this matrix does not have an inverse matrix, okay? Which makes sense because the determinant goes on bottom and we can't divide by 0. We get an undefined answer and there's nothing we can do after that point. So, intuitively kind of makes sense there. All right, guys. So give these 5 a shot. Right, you're just being asked if they have an inverse, not whether or not, not what the inverse is. So you're basically being asked, is the determinant 0? Oh, never mind. Find it. Reading helps. Except for the 3x3. Finding the inverse of a 3x3, you guys are only ever going to be doing through a graphing calculator. So, I'll walk you through the first one, and then I'm going to let you guys do the rest of them. Pause the video when I'm done with the first one. I'll put up the answers. You can check. At least that's the responsible thing to do. And then we'll move on to the last section here. So we've got -4 times 3 minus -2 times -6. That's going to give us -12 minus +12. Add the opposite. That gives us -24. So this one does have an inverse. 1 over -24 times the original matrix, but with swapped spots, right? We got 3, -4, 2, and 6. So the inverse is going to end up being -3 over 24. I'm going to zoom in here. 1/12, 1/4, and -1/6. It's going to be the answer here. All right, so yeah, like I said, pause the video because I'm going to pause this and put the answers up. So the next instant is going to be the answers shown. All right, give it a shot. All right, guys, so here are the answers to those two. That's a -2 on the right. I know this pen is fading on me sometimes. And then down here, you know what? I realized I just forgot to find the inverse of this one, so I guess I'll do that really quick. 1 over 40, 3 and 10 swap, 2 becomes negative, 5 becomes positive. So the inverse here is going to be 3 over 40. This one will be -20, 1 over 20, right? Sounds about right. And then we've got 1/8 and 1/4. The determinant to this fellow ends up being 1. All right, now for the most important part. Finding the determinant and how to find the inverse, knowing what it is the most important part. But what you are probably going to really enjoy when you get past the fact that an easy way exists to solve these and you had to solve them the hard way. So as soon as you get over that part, I'd imagine you'll enjoy this. Okay, so you might recognize these. These are from chapter 1. We have a systems of equation. We have a 2-variable system on the left. We have a 3-variable system on the right. You can actually solve these using matrices. So first, let's talk about balancing an equation. If you wanted to isolate x in this equation that I've just created, how would you do it? Okay. The a is multiplying the x, so you would divide by the a, right? And now X is by itself, B divided by A. Okay. But we have not taught you how to divide matrices, right? We've taught you matrix addition, subtraction, multiplication, but we have not taught you division. And that's because it doesn't exist. So if we look at this in a different light, and we imagine each of these as their own matrix, matrix A, matrix X, and matrix B, how do we get matrix X by itself? Well, why did we choose division in the earlier, when I earlier posed this question? Because division is the inverse of multiplication. Now you know how to find the inverse of a matrix. So we multiply both sides by the inverse of the matrix we're trying to move. So it ends up being inverse A times matrix B. And this will just spit out our answers. So instead of, having to eliminate a variable, solve for it, plug it back in to find the other one, or in the worst, in a harder situation, like a 3-variable one, we're going to talk about this one down here, where you have to create 2 equations that you've eliminated a variable, then you have to eliminate a second variable, and then you have to find the one you didn't eliminate, and then you have to go back and find all the missing ones, right? You remember that process? It was awful. You can just plug it into your calculator and it'll do all the work for you. Okay, so let's talk about what that looks like. You're going to create 3 matrices. The first one is the coefficients: 10, -9, 7, and 6. Okay, so that's the left side of the equation. This is your A matrix that I was talking about earlier. There is a middle matrix that's really just for show, but this is our variable matrix. This is going to be our answers and what they're given to us, how they're given to us by the graphing calculator. X will be the first one, Y will be the second one, Z will be the bottom when we do a 3 variable equation. And then the last equation is going to be the last matrix. So if you're watching this, chances are there's a good chance that you don't have a graphing calculator nearby. If you do, then hopefully this goes down a little bit more smoothly. If you do have a graphing calculator, I don't have one by me, so I'm doing all of this from memory, so please bear with me. When you're solving this with the graphing calculator, you're going to hit the second button, and then you're going to hit the X to the -1st button. That will take you to the matrix page. Okay. And then you're going to go right twice. It'll take you to the edit menu. That sounds like a good word. In there, you'll see a bunch of these: A, B, C, and so on. You're just going to press enter on one of them. You'll have to create, you'll have to pick your dimensions. So for matrix A is what we're doing first, right? You're going to want to pick a 2x2. And then you'll have to fill out the entries. So you'll just press all the numbers that you need: 10, -9, 7, and 6. You want to go back to the main like blank page of the graphing calculator, I normally just press graph, which is the top right button right below the screen, and then I hit the clear button right below that. That's how I like to do it. There are other ways, but I'm just used to that. I'll do graph clear whenever I want to go back to the main menu. And then you repeat that process. So you're going to hit second. You're going to hit the inverse button. It'll take you to the matrix page. You go right twice to get to the edit section. And now we're going to click on B and hit enter. And now we want a 2x1. And you're going to put in the answers, right? Like our equals to. So 1 and 13. For simplicity, I'm going to name this one A and this one B. Right? Those should be the first two in your graphing calculator anyways. Once we have those two created, and you go back to graph clear, we need to be on the main page, the blank page. One final time, you're going to hit second. I lied. You're not going to hit, this is not the final time. You're going to hit second. My thing is all messed up now. You're going to hit second and then the matrix button. You're going to click on A. You're going to hit the X inverse button. Hold on, I have to. You should kind of listen to my instructions for right now because my OneNote is messed up. Actually, let me pause this and let me see if I can fix it. All right, hopefully this is fixed now. So you're going to go to the matrix menu, hit second, the inverse button, which is X to the -1 power. You're going to click on your A matrix that you created. You'll press enter. It'll take you back to the main page with just the A in the brackets. And then you press the X to the -1st power without pressing the second button. It should end up looking like this. And then you do the process again where you hit second and the inverse button, and then you go click on your B matrix and you hit enter. Okay. What you're telling the calculator to do now is inverse A times B, which is what I was talking about up here. And that should give you your answers. You should get this as your answer. 1 for X and -1 for Y. All right. I'm going to quickly go over the instructions for a 3x3. It's basically the same process. You just make a 3x3 instead. You should practice this one, but I just want you guys to know that the answers are something like 9 over 153 is like, I think your Y value. Maybe it's your X. I'm not really sure. No, I think it's your Y. The other two are similarly not fun. Maybe like 41 over 153. They're all over 153. If you use your graphing calculator, they'll show up as decimals. If you hit math and then you just hit the fraction button, it just says FARC, it'll change the decimals to the fractions, and then you can see. I know 153 is definitely the denominator here. Like I said, I currently do not have a graphing calculator on me. All right, so you guys can try this one, and I'll show you how to set this one up. So we've got our first is 9, 2, 3, -8, -3, -4, 12, 1, and -2. Our variable matrix, and our answer matrix. Okay, so this is our A matrix, this is our X, this is our B. So you want to do the whole process again, just reminding you, go up here, you hit second, you hit the inverse button, you go to the matrix page, you go right twice to the edit section, you click on, it doesn't have to be A, it could be whatever letter you want it to be, you're just naming it. Instead of a 2x2, we now need a 3x3. You put all of the entries in just the way they look. Okay. The most common mistake that people make is entering the numbers. Okay. Make sure it's the right number and the right sign. It's one of those things that sounds really simple, and it is, but it's just the most common mistake that happens. So be careful. And then we go through this whole process again, create it, go back to the main page. I hit graph clear. There's other ways to do it. Like I think you can just hit second and matrix button just to go straight to where you need to, but I prefer graph clear. Makes me feel more comfortable about it. Do the process again, create your B matrix, your answer matrix. It's going to be a 3x1 this time, right? Because we have one more variable to solve for. And then you do this over here, right? Click your 3x3, hit the inverse button, go find your answer matrix, and then press enter again at the end, and you should get your answer. Okay. Last couple things. Here's the answer to that one: 0, -7, and 5. And this one was a no solution. These ones you should be able to do just fine by yourself. 2x2s, or just two systems, a two equation system. The word problems, best on your own. I set the first one up for you, but it's the same exact process. You can just create your matrices, plug them in your graphing calculator, and find the answer. All right, guys. I hope this helped. If you missed that day, you can go back, watch it again, look at other parts, slow it down, whatever you need. And that is it for me.